All right, we're live, and I've started to bring up the factory manufactured boards, and I discovered that there is a fault on these boards, which is somehow related to the regulators. I think that it is the 5-volt regulator that is probably mounted wrong, but this is what I'm going to double check in this video, and I'm going to get down to this problem and figure out exactly what is wrong with the boards. The net effect is that when the power is turned on and the power supply voltage is increased gradually, I can see that there is well, first of all, everything is working, but then once the voltage goes above 7 volts, I could see a puff of smoke somewhere on this side, and then the voltage on the 3.3 volts that is not going to the CPU, that's going to the 3.3 volt chips on the board, is suddenly set to the input voltage, which is obviously not very good. And the reason that I think that it is the 5-volt regulator is that the voltage on the 3.3 volt rail is increasing even before the 5-volt regulator has actually come up. So that is something that is not supposed to happen when the 5-volt regulator is working properly. So I'm going to start checking this board, and the first thing I'm going to check is whether the 5-volt regulator is actually connected properly here. So I have two test points, which is TP19 here, which is on the output of the 5-volt regulator, and then there is TP15 here, or TP16 here. And I'm going to check if there is any kind of short here, and if this one is okay, then I'm going to check this regulator as well. But I'm going to start with the 5-volt regulator, primarily because it's a chip that's one of those regulators that I haven't used before, and it's kind of possible that maybe I created this footprint in such a way that it's actually not oriented correctly. Maybe it's not oriented according to the orientation of the chip on the tape. So when I mounted this manually, obviously I mounted it correctly, but it's possible that maybe the factory mounted it wrong because it's maybe not oriented correctly according to the tape orientation. So that's something I'm going to double check as well. But let's check if there is a connection from the output of the 12-volt regulator to the input of the 3.3 volt regulator. So I'm going to check TP19 and TP16 here. Let's see. So I'm going to put this there, and I'm going to check test points. Let's see here. TP16 and TP19. Let's see. Is this really short? It's kind of sounding sometimes, but it looks more like... Okay, that's absolutely short. So next thing I will do, I will actually check if this regulator is oriented correctly. So I'm going to double check with the datasheet and see if I can see some fault here. Let's see, properties. Okay, I need to find the datasheet. So let's find the datasheet for TPS 62147. I'm going to also update my component. So I'm going to go to the library and update the field. Datasheet. Okay. And let's have a look at the datasheet. Where is the package information? So my footprint looks okay according to the datasheet. But could it still be mounted wrong for some reason? Why is this pin 1 area marked here and not here? Because when this one is rotated, this one is upside down, so when it's rotated, kind of pin 1 happens to get placed here, so it's supposed to be here, I would guess. Let's see. What I could do is compare this to the way that I mounted the chip on my board. And the thing is, I would need to I have some flux on top of it, but I think that this one is actually going to be visible. So let's have a look here. I'm going to bring up the microscope. And we can have a look at one of the boards that I've assembled myself. Let's see. This one is placed like that. Actually, this one has a short. Let's have a look. There are two pins though that are connected together, so this could actually be the two pins that are supposed to be connected together. This is the third board that I haven't been testing yet, but the chip should be sitting exactly the same way on all of them. Actually, I think that this one should be working. I'm pretty sure I tested the regulators on this one as well. Yeah. Let's have a look. So this one is going to be it's going to be these 2 pins. No, it's going to be these 2 pins here. Okay. I'm going to check the board that I know works for sure. This one, I don't think that I would be able to actually see the text on the chip because there is flux here. I would need to remove the flux. I have another board here. Yeah, I think this one is going to be fine. Yeah. So it's mounted like that. So the text is supposed to be facing towards the inductor here. Let's have a look how it's mounted on the factory assembled board. Maybe it's mounted correctly, maybe it's not. Oh, this one is actually mounted correctly. So could it be something else then? Maybe it's not this chip, maybe it's something else. So why is 5 volts shorted to the input? So looking at the board that I have been using, which I have assembled, there is no short between the TP19 and TP16. While on the board that is from the factory there is a short. There seems to be a short. So the next thing I'm going to do actually is I'm going to remove the resistors that I used for current sensing, so that I can disconnect everything that's connected to this regulator, and I'm going to check if it actually works. Let's see. I will start from this side actually. So I'll remove the resistor that connects the 12 volt regulator, and I'll just make sure that the 12 volt works first, and then I'll move on to the 5 volts and see if that one is working as it should. And then let's see. I see one thing that I see is that the inductor is rotated 180 degrees, which shouldn't really matter, but that's just a detail that I can see right away. But I'll start by removing the R. Let's see which one I could remove here. R55. I'll remove R55. The factory also uses unleaded solder, so it's a little bit. It has a little bit higher melting point. It's not as easy to solder as with the leaded one. Okay, there we go. Almost there. Alright. Now I just need to pick it up and move it to the side. Okay. So now I'm gonna check. I'm gonna let it cool down a little bit. Okay, and now I'm going to check if I get stable 12 volts on the 12 volt regulator. Let's see. To check which side of the resistor I need to measure. So R55 is here, and it's going to be this one. This one, actually. Yep. So let's have a look at it. So I'm going to increase the voltage on the input gradually. 3.9 volts, 3.5. Now it's 5 volts. So now it's turned on. So now I'm going to increase it above 12 volts. Make sure that it stays at 12 volts. So now the input voltage is 13.5 volts. Yeah, it's working. There's nothing wrong with this regulator. All the way to 20 volts, 22 volts, 23, 24, 25, 29, 30. So that's how far my current power supply here goes. Let's see. Okay, so time to put back the resistor, and then I will check the 5 volt supply. So I'm just going to make sure that it's completely discharged. So because there is no load right now, the capacitor that is on the output of the regulator is not going to discharge, so there is still some voltage on it. Now it's down to below 1 volt and going down, 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 down. 0.1 volt. Yeah. Now it's completely discharged, so I can put back the resistor and solder it on. I should really have my fume extractor running. My custom-made fuel extractor. The resistor is mounted now, so I'll just go ahead and remove the other one. So the other resistor is going to be the one that goes from the 5 volt regulator to the 3.3 volt regulators. It's going to be this one here. R61. So once I remove this resistor, I can at least make sure that nothing breaks if this 5 volt regulator is not working, because nothing else will be powered. Okay, the resistor is off. And it's time to check the 5 volt regulator. So I have the voltage down now, again, and I'm going to increase the voltage gradually until I get an output on the 5 volt regulator. Let's see. So going up to 2.3 volts, 4.3 volts. This doesn't look really right. Like, this doesn't look right at all. This looks like the 5 volt regulator is just not working. This is why it's good to have Zener diodes on the output of regulators, because Zener diodes provide protection against this kind of fault, which can happen if the regulator is not working. So let's see. So what could be the problem here? So the input voltage is coming in here, and it's supposed to be coming out over here. This is the inductor, and Maybe I should just remove the chip and check what it looks like underneath. It could be that maybe there is too much solder paste underneath the chip. So it's just shorted between the inner pads. So I'm gonna do this, and we'll see. So I have my voltage now set to 0 volts on the input power supply. Yeah, I need to fix this smoke extraction. Not coming out that easily. I'm thinking almost that I perhaps should increase the temperature. Right now I have it set on 260 degrees. Inductor came off, but not the regulator, not yet. The regulator has ground pads that are connected to the ground plate, so it has some heat sinking to the ground plate. Come on. I'm going to increase the temperature a little bit. See if 270 degrees and get it off quicker. Now, alright, cool. Okay. Checking the pads. Looks like there was a solder ball. But it doesn't look like it's, well, it looks a little bit like there is a bit too little solder paste. Like some of the pads are haven't actually been soldered, like this one. But I'll try to, actually I'll check if there is still a short. Let's see. I'm gonna wait until this cools down a little bit. And I'm gonna fix I'm gonna remove this solder ball that is shorting some of the pins. A bit of flux. And to make it a little bit. Okay, now it has cooled down sufficiently that I could actually test if there's still voltage on the output. And if there is no voltage, if the input voltage doesn't get to the output now, then I'll just try resoldering this regulator, and then we'll see if it works better. It could be that the regulator wasn't actually running If some pin is not connected, it could actually just be outputting the input voltage, because it's a switching regulator. It switches the inductor using the input voltage, and if the regulator is not running, then it could very well be that the input voltage is actually just going through the regulator and onto the output. But that still doesn't explain why I had a short from the input to the output. Let's have a look. So, increasing the voltage. Yeah, there is nothing coming through. And on the input we have, let's see, do we have anything here? Yeah, we have 7.8 volts on the input. Let's see. Yeah, 7.8 volts. Nothing coming out. So there doesn't seem to be a short. I'm just going to double check against the test points. There is no short. So maybe there was actually a short underneath the regulator. So what I'm going to do now is just solder it on again and see if this works better. I'm going to use a lot of flux to make sure that any kind of solder that gets in between the pads gets sucked onto the pads. Alright. Okay. We'll see if this is actually soldered on properly now. these pins are connected together. Yeah, it's looking, probably it's okay. And next step now is just to check if there's a short, and once it cools down, then I can check if I get the input voltage on the output again. There doesn't seem to be a short anymore. So this is, or is there a short? When it beeps a little bit, it usually does that because of the output capacitors of the regulator. So if the output capacitors are not charged, then it will beep a little bit, and then it will not show that there is a short circuit. So now I'm just going to wait until this cools down, and we'll see. Hello, Damien. Alright, I think it's cooled down now. So now I can test and see if I get 5 volts on the output of this regulator. Let's see. Increase the voltage. And input voltage is now at 5 volts, but I get really weird. I got a lot of current consumption, so that's not good. That means that there is a short somewhere. Let's check if there is a short on the output of this regulator. Check to P16. Short there. That's a bit weird. Current consumption is very high. it's not actually working yet. Let's see what happens on the input. So the input should go to 12 volts. Yes. But the output seems to be shorted. So I need to resolder the chip again. Kind of don't get the same reflow as I do with leaded solder. So it's kind of it's hard to tell if the chip is actually properly soldered. I may need to just clean out the pads and use some leaded solder so that I get this behavior where the chip is actually if I pinch it, it should go back to its original position. But right now it's kind of slow at doing that. And I don't want to have too much solder because it can easily short the pins. It's quite a tiny chip. Can I have a look here, maybe? That doesn't look like it's actually soldered on. Okay. I'm going to put on a little bit more solder on the pads. Okay, now I can pinch the chip a little bit and it goes back to its original position. So I should get a much better result when soldering it like this. Yeah. But I could still have put a little bit too much solder on the pads. But we'll see. I'm just waiting for it to cool down before I turn on the power. I'm slightly worried that maybe when I was heating it up for so long just to get it off, maybe that was too long. I don't think that it's a problem. The chips should be able to handle a bit longer heating time, and it's not a very high temperature. I've been heating it with 260, 270 degrees at most. Now I think it's cold enough. So let's have a look if this works. I'm going to connect the multimeter, reverse polarity, doesn't really matter. It's just that the voltage is going to appear as negative voltage. And I'm going to increase the voltage on the input. Alright, this looks much better. But it's not regulating, but at least it's not consuming half an amp either. So something is wrong with the regulation. However, this is a little bit better than before. But there is still something wrong with the regulation. So it's not actually regulating. Now let's see. Yeah. So it's actually ending up at being at 10 volts when it should be 5 volts. So let's see if there is something wrong with the resistors maybe on the feedback path. So the resistors that regulate the voltage is these ones here, and this needs to be. It's kind of annoying that I can't actually check the connections from the chip. So I should have actually added more test points here, so that I could check whether some of the pins are shorted to something else. But I can't do that right now. But I could still check if the resistances are correct. Let's check across R58 what we have in terms of resistances. Where is R58? $35K. Wait a minute. I guess I could, yeah, I could only check the correct resistance here if I remove the resistor. Actually, what I could do is measure the voltage when the regulator is running. If the voltage is, the datasheet actually says what the voltage should be on this feedback pin, and I think it's something probably like 1.2 volts. And when the voltage is 1.2 volts, then the let's see. I'll have to check the datasheet exactly what value I should expect here. But I guess it would be the value of the, if it's regulating correctly, then it should be the value of this resistor divider. which would be, let's have a look. Let's see if I remember the formula for resistor divider. So 147K divided by 147K plus 147 plus 23 times. Could this be correct? Maybe it's 23 divided by 47 plus 23 times 5. 0.67. I feel like an idiot if I don't remember the formula for resistor divider. As always, I'm going to check Google. Because I don't remember this value of 0.67, and neither do I remember the value of like 4.32. So let's see here. Yeah, it was. It's supposed to be this one. So 0.67. That doesn't sound really correct to me. But the circuit was working on my other board, which I soldered manually. So it must be the correct circuit. It's just that something is wrong with the connections on this regulator on the factory manufactured boards. Let's see if we get 0.67 on the feedback pin here. Okay, increase the voltage and get this. It's not really correct. This doesn't look correct at all. Let's see. Or 1.45. It's like it seems to be regulating, but not at 5 volt, but instead at 10 volts. So something is off here. Could it be that something is shorted here? Maybe one of the resistors is actually shorted. I'm gonna check with a microscope and see if one of the resistors is shorted. Why is this 170? It's supposed to be 170. is it regulating at 10 volts and not 5 volts? Okay. I'm gonna check the resistors. Okay, we soldered the resistors, and it's time to check them, just to make sure that we have the correct resistance. One of the resistors is 10K. Another one is 3K. And there should be another one that is 10K. Let's see. Yeah. So these resistors are correct. Yeah. I'm going to resolder them and continue the debugging process. We should decrease the airflow a little bit. Something that I also want to check is whether this works better after resoldering the chip on a different board, because all of the boards seem to have the same problem. And if the regulator is somehow broken on this board, then doing the same change on a different board may turn up different results. But I'm gonna try to fix this board first, and I will only move on to a different board when I've exhausted any possibilities that something is wrong with the surrounding components here. Let's see. I need a bit more flux because solder joints are not soldering properly without flux. One resistor just keeps sticking to the tweezers. Come on. Slowly on, come on. God damn it. It's actually sticking to the tweezers. I have too much flux on my tweezers. Okay, this worked a bit better. I need to kind of clean up my workspace and mount the microscope so that I can solder at the same time while looking at the screen of the microscope. Let's see. So the voltage on the output of the regulator. I'm gonna check the voltage at the feedback pin and just or actually no, I'll check on the output right away. This doesn't seem to be soldered on properly. Probably not soldered either. Actually, that was better. But it's still regulating at 10 volts for some reason. This one actually goes beyond 12 volts. Oh, come on. Yeah, this one gives the input voltage. Okay. Still having a short here or something. No short this time, but it's still not working. But is this one actually connected to ground? That's weird. Or? No, it's not. Yeah, that's correct. No, it's not an issue. But what is up with the regulator? I'm gonna try this with a different board, and I'm just gonna desolder the regulator and
solder it back on again. Okay. So this is a board with a similar problem. Let's have a look if there's a short. Yeah, this one has a short on the output, just like the other board. So there is something wrong with the soldering. Maybe I could just heat it up and make sure that it reflows, and perhaps that would fix the issue. I'll see. I'm going to resolder the inductor as well, just to make sure that it's properly connected. This unleaded solder is just a pain to solder by hand. So I'm just gonna thin the pads a little bit with leaded solder. And then I can get the inductor in place. chip off. Chip is still soldered hard. Like, do I really need to increase the temperature more than this? Okay. Now it seems to be a little bit wobbly, so I'm gonna let it cool down, and then I'm gonna try to power it on again. And also one thing I'm going to do is remove the resistor on this board as well, so that I don't power any components with high voltage. This is the current sense resistor that sits on the cloth between the regulator and the rest of the circuitry. It uses 5 volts. is gone. Still a bit hot. Okay. Time to see if there is a short here. Doesn't seem to be a short, and let's see what the voltage ends up being. Look at that! It's actually working. It's actually working. Okay, so this one, it could be that the other chip on the other board was overheated or somehow broken because of the short, but this seems to be working. So I will just resolder the resistor and see if I can actually get this board powered up. Let's see. So I need the current sense resistor back on the board. All the power is turned off, I mean, and I'm gonna just get the resistor and solder it where it should be. Let's see. No! Resistor just jumped out of my tweezers. Luckily, I can see where it is. Resistor. I'm gonna move this away so that I don't get everything tangled up here. Okay, time to get this resistor on the board. I want to have some normal solder that actually sticks. The unleaded solder is great for complying with all the regulations and great for factory assembly, but not for hand soldering. There could be certain types of unleaded solder that actually are easy to solder, but personally I think that leaded solder just melts a lot better and is easier to work with. Let's see. Yep. Let's see if this powers on the 3.3 volt regulators, just to make sure that we're going to have power to all parts of the circuit. And there's something that went up in smoke when I was powering this on when the 5 volt regulator was shorted. So I'm just going to go slowly and see if there is any shorts that could have been caused by that. Nope. Why is this going beyond 3.5 volts? 3.3 volts it's supposed to be. But it's going above that. Let's see. It could be that the LDO is broken now because of the short. This one's at 3.3. Let's have a look. This one is at 5. No. Don't go up. Yeah, I think the LDO is broken. So I will just see if I can replace the LDO. I'll see if the factory actually provided parts that I can use for replacement. I have a lot of parts from the factory that are like leftover parts. So I'll see if there is an LDO here. Could there be an LDO in this pile of plastic bags? Some of the plastic bags are actually empty. This looks like 40. Let's see, 145858. Could it be the LDO? I'm gonna check the actual article number of the LDO. It would be TLV 75533. So it's not that one. This LDO can only handle up to, here's the LDO, unless this bag is empty. Unless this bag is, and it's empty. Yeah. So we don't have any LDOs. But what I could do is actually take the working LDO from the other board. The one that was used for CPU on the other board. And I can debug the other board later. So what I could do is actually do like this. So just to get this board running, I'm gonna take LDO from this board, and I'm gonna take the one that that I know is working. Let's double check that it's working. So this one, actually I'm not going to check that it's working because I need to solder on the resistor to check that. So I'll just remove the LDO from this board and see if the other board works. Some flux there, and remove the LDO. And the LDO is off. I'm going to take the other board and I'm going to change the LDO that is used for powering all of the other components besides the CPU. So I have two LDOs, one is for CPU, one is for other components that use 3.3 volts. So I'm going to remove the one that powers the other components, which seems to be broken. So we'll see if this works better with the new LDO. And then I can repair the other board after I order a few more of these LDOs. Okay, this one is off. I'm just going to tin the pads with some of this leaded solder. Did I just pick up the right one? I think it was the right one. I think it was the other one that was broken. Okay. A bit more flux. I'm just going to make sure that the solder joints are okay. With this solder iron. Okay. I'm going to wait for it to cool down. And then we can do a test. And now I'm going to check if I have 3.3 volts and that the 5 volts is still working. And if I have all of the power rails, then I can try to flash the chip and see if I can bring up the operating system on this. Let's see. Or actually, I should just say bring up the application because there is no operating system. It's running FreeRTOS for scheduling, and then it runs a lot of custom code. One thing I actually want to check here is the solder mask over here. Let's have a look at the solder mask on the pads that are used for this regulator. See, there is no solder mask because the spacing is so small that the keypad area makes sure that there is no solder mask, and that's why they short. This is why they don't really solder properly. The solution to this problem is to reduce the distance between solder mask and pads, so that solder mask can actually appear between the pads of this chip. Because Otherwise, this is going to be the issue with every single board manufacturer. So this is something I need to fix, and it's an easy enough fix to do. The only problem is that I would need to resolder the chips on the 6 board that I got manufactured right now. But once I fix this, it's going to be, I think it's going to be perfect right out of the factory. Let's have a look. So, it's time to check whether this board is working now. Oh, there is another little issue. I need to fix this resistor because it wasn't soldered properly. I'm just gonna fix the resistor. This current sense resistor. Have to have a little bit more solder on it. Come on. Okay, come on. the solder that that is used by the factory for the solder paste and my own solder, they don't seem to really mix very well right away. So I have to heat up the part and wiggle it a little bit until I can see that the solder joint is perfect. So let's see. I'm gonna let this cool down. There. So just waiting for this to cool down now. Alright. I'm gonna check the 5 volt. So it's still working. Oh, of course. God damn it. Yeah. Let's see. Well, that was stupid. Should work better now. 5 volt is on. And about 3.3 volts. Nope, still not working. Maybe this will be all it does, supposed to put up there. It doesn't seem to have had very good solder joints. It's kind of the same issue with all of the components that are soldered with this light green solder paste. Maybe if I get the solder joints connected properly, maybe it will work better. volts, no. Okay. I'm expecting to get 3.3 volts on this rail, if you haven't been watching this video from the beginning. It's ending up being quite a long video, but the goal is to fix this board, and it doesn't matter how long time it takes. I'm going to get this board fixed anyway, and then this board can actually start being tested. Seriously. No way. Dang. Okay. I still get 5 volts here. Yeah. At least 5 volts is working. But 3.3 volts is not working. Let's have a look what the problem could be with this 3.3 volts regulator. Actually, I think I know what the problem is. So, I think that it has something to do with the fact that some component burned down, which was connected to 5 volts before I fixed the 5 volt regulator. So on both of these boards, something went up in smoke when I increased the power supply voltage. And it could be that actually this component has both the 3.3 volt supply rail and 5 volt supply rail. If the 5 volt supply rail has had too high voltage, maybe that supply rail actually shorted into 3.3 volt supply rail. So maybe the reason I'm getting higher voltage on the 3.3 volt supply rail is because one of these components that has dual supply voltages has actually been destroyed. So what I'm gonna check right now is
I'm going to see which components are connected to both rails, and I know for a fact that I have the CAN transceiver is connected to both rails, and the smoke was coming from the side where the CAN transceiver is, so it could actually be the CAN transceiver that's been destroyed. The second chip that uses both 3.3 volts and 5 volts, I think it was the LED driver. Could it be? No, the LED driver is not using both voltages. I think that most probably this is the CAN transceiver. Then I have the op amps that use both voltages, but op amps are usually quite robust to over voltages, and it wasn't really very high over voltage. It was maybe 7 volts, and at that point something broke on the side of the CAN transceiver and the USB port. So somewhere near the CAN transceiver or the USB port over here. This is where I saw the smoke. I'm going to try and remove the CAN transceiver and see if I can get 3.3 volts on the 3.3 volts rail. Let's have a look. Remove the cables from underneath here. We don't burn them. I'm going to use this much hotter soldering iron, which I have set to 360 degrees, just to melt the unleaded solder, so I can get rid of this chip faster. Okay, the CAN transceiver is off, and now we can power the chip, the board on again, and see if we have 3.3 volts here. Let's see. So. Nope. I still don't have 3.3 volts. What I'll do is actually, I will remove the resistor that connects this regulator to the rest of the board, and I will see if I get 3.3 volts that way. If that gives me 3.3 volts, it means that there is nothing wrong with the LDO, and then I have to search for the possible short that can be caused by having had over voltage on the 5 volt rail before. So I'm gonna do that, and we'll see if we get 3.3 volts on the 3.3 volts regulator.
resistor just doesn't come off. And I can see it's getting too hot, but it still doesn't come off. I'm gonna use some of the leaded solder to lower the temperature of the melting point of the solder on this on the pads of this resistor, so I can just get it off quicker. And then it just comes off right away. Okay, let's see. It's a bit too hot right now. I wonder if the resistor is still okay, because it looks like it kind of started to melt. No, the resistor is not okay anymore. I'm going to have to replace this resistor. And we get exactly 3.3 volts. So something on this board, after being fed with more than 5 volts on the 5 volt rail because of the short in the regulator, something is now shorted to 3.3 volts, and I'm going to try to find out what it is. So let's see where the 5 volt goes on this board. So we have the output of this regulator comes out to the resistor, and then it basically comes out here. Let's see. So one of the chips that is connected to this 5 volt rail is shorted to the ground, or actually to the 3.3 volt rail. So let's have a look here. What is this? This is the USB. So which one is connected to 3.3 volts as well? I think it's the only one that is also connected to 3.3 volts is this one, and the other one. So it's the encoder interfaces, which is kind of unfortunate if one of these is broken. But I'll have to remove one of the. I'll have to remove both of them actually. But I can start with one of them and see if that fixes the issue. and otherwise I'll have to remove both of them. This is going to be quite a pain because of the unleaded solder paste. Maybe I can get this solder paste to actually melt better with some of the leaded stuff. Maybe I can get this leaded stuff on the pins. I'm going to increase the temperature as well. Let's see how well this goes. So I'm going to remove this chip and then I'm going to solder back the resistor, which I'm going to replace with a new one. Probably just a 0 ohm resistor. Actually, I could use this one. I have one of the resistors that I soldered, desoldered from the other chip. Okay. And this one. Actually, I could see if I get any results right now. To lower the airflow a little bit. Where did this resistor go? Where did the resistor go? There it is. I'm just going to check if this resistor is still okay. Did it get blown away again? Where is the resistor? I think it was this one actually. I have to check if it's still working. Yeah, this one's still working. Solder this one, and then I can check if I still get 5 volts on the 2.3 volt rail. next I'm going to remove the other chip here. I have to increase the airflow when I desolder the chip, but then remember to decrease it if I start soldering some components, otherwise the component will get blown away. The chip I'm desoldering right now is the encoder interface, the second one, which I suspect could be responsible for shorting the 5V there to 3.3 volts. So maybe one of these encoder chips is destroyed after feeding it with a broken 5V regulator. We'll see. Come on. Yep. Almost. No. There. I hope I didn't break any pads. That would be just totally fucking. Damn, this solder paste is very bad at melting. I think I lifted off a few pads. I'll have to just make sure that I solder them properly later. At least they're not broken. I don't think they are. Okay. Now I'm going to check if I get any voltage here. See if we get the correct voltage. So we're looking for 3.3 volts, not 5 volts, not anything above 3.3 volts. And now we got 3.3 volts. Awesome. So, what I'm going to do is solder back one of the chips. Let's see, which one was it? I think it was this one. I'm going to solder this one back on, and this board is going to have only one encoder chip, for now at least. I'm going to solder it to this footprint that I almost destroyed by lifting up the chip when it was not properly desoldered. I'm going to use a lot of flux, and I'm going to tin the pads of the chip as well, and maybe it will just work. We'll see. Or maybe both of the chips are broken, in which case it probably won't work. In which case I'll have to remove the chip again. And also in which case I'll probably destroy the pads completely. But luckily some of these boards don't need those chips. orientation. It's like this. So it's supposed to go on like this. Okay. We're going to heat it up. Okay. This one seems to be soldered all right. And next step is to make sure that it cools down, and then I'll check the 3.3 volt rail. And if the 3.3 volt rail is going above 3.3 volts, then I'll have to remove the chip again. Then both of them are destroyed. Okay, let's have a look. I'm going to be gradually increasing the voltage. So I've got 3.3 volts, and it seems to be at 3.3 volts. That sounds good. Now it could also be that the chip isn't actually soldered properly. Maybe something is not connected. Maybe that's why it's giving. Maybe that's why it's not actually shorting 5 volt rail to 3.3 volt rail. But the way to check that is I'm gonna power on the board, and I will flash it with the firmware, and we'll see if the firmware can detect the chip. Let's see. And maybe I will need to eventually do some change to the code because the chip that is the other chip is not mounted now, so the firmware will probably complain that it cannot find it, which I'm pretty sure it will. Let's see. So this will go to the ground here, and then I'll connect the serial port as well. Look. The serial port goes here. The ST-Link goes here. So let's have a look if we can talk to this board. So I will try to flash it. So this is the console that will output the text that's printed out by the firmware on the board. So we should be seeing similar text here if the board boots. Once I've flashed it. So first of all, I'm going to try to flash it. Let's see. flashing. I have to check to make sure that nothing is actually, I'm gonna do like this. I'm gonna disconnect the Steelink and try again, because sometimes that's the issue. Nope. Okay. Let's have a look at the voltages. So this will be the voltage on the CPU. Make sure it's at most 3.3 volts. Yes, it is. That's good. It could be that the CPU is destroyed as well. If the encoder chip got destroyed, then it's quite likely that the encoder chip was outputting more than 5 volts to the CPU. Maybe the CPU is destroyed as well, which would be kind of unfortunate. But this is the kind of stuff that happens if the regulator is broken. So that's 3.3 volts as well. This is the peripherals. So the only thing that that could be preventing me from flashing this is probably that the CPU is actually destroyed. I'm gonna check to make sure that that I get the debugger signals delivered to the CPU. Let's see. So I've got this Steelink connected here. Also, I want to just check something. I want to see if core status unknown, memory region. Yeah. So basically, it cannot identify invalid flash type. Check device declaration. Yeah. Okay. No connection at all. So this Steelink is connected to this pins. This is the I/O and this is the clock. Let's see. Let me just double check this. Maybe I screwed up the wires here. Sure. Let's see. This is actually, is this? Yeah. This B. Actually, it's supposed to be like this. The ground goes over there, and yeah, this was correct. And the I/O goes there, and the clock goes there. Yeah, so it wasn't any issue with the connections. So next I'm gonna just check that this arrives at the correct place on the chip. So third pin there, and let's see. I goes there, and this one, the clock goes over there. Okay. bring up the scope here. Let's have a look if the CPU is actually nuked on this board. So this pin is now this is the clock pin. So this is the clock pin, and it's supposed to let's see. We're supposed to be seeing a clock here when I do the flashing. If we see a clock, I'm going to check the data pin, and if both of them have data but no response from the chip, then the chip is broken. Let's see. So I'm just going to place this over here, and then I'll have this window. And I can see the screen of the scope in front of me, so I don't need to have that window there. Let's see. Maybe I could select like a single or normal, and then level, menu, channel 2, and let's see. No. Is there nothing there? Let's see. Yeah. So now we can see the clock there. The clock has the clock seems to be working. And after this, the ST link doesn't try to communicate with the chip until it's plugged in again. So I'm gonna plug it in again, and I'm gonna check the data pin as well. And the CPU seems to have power. Everything seems to be fine in terms of the connections. It's probably just the CPU that's completely broken now, unfortunately. So let's see here. The data pin doesn't seem to be. Let's see. I'm not getting anything on the data pin. Let's try again. Plug it in again, and I'm going to check the data pin again. Okay. Yeah, and there is several retries. It looks like it's several retries, but still no communication from the chip. so I think the CPU is broken. I'm gonna put this board aside, and I'm gonna try to bring up the other board that also had a similar issue, and after that I'm gonna try to bring up a board that hasn't been powered before, but I'm gonna fix the 5-volt regulator before powering it on, and then we'll see if the CPU works there. I'm gonna stop this video. I'm gonna start a new video just right away, so if you're still interested to see how well this goes, then just reconnect to the new stream, and we'll take it from there.